All right. Good morning, everybody. Thanks for joining our webinar. This is our third webinar in our webinar series. We host one once per quarter. Today's topic will be industrial operation and maintenance practices through predictive intelligence. First, I want to start off by introducing our speakers. So we have our technical solutions manager, JU, our business development manager, Buddhi Thenuwara, and myself, our sales development representative, Tyreace Smith. Now, who is ONEPREDICT? We are a leader in the industrial AI technology space, focusing on the health of industrial assets. The core of our business focuses on prescriptive digital twin solutions for motors, transformers, and turbo machinery. ONEPREDICT was founded in 2016, and today globally, our team consists of 90 members with over 70% dedicated to research and development, improving our algorithm, and refining our user interface and experience. We are very much a technology-focused company, recognized as a global top technology company in the industrial AI space. Currently focused on rotating machines and electrical systems, soon we are rolling out a product for discrete manufacturing. We have won over 40 awards in global predictive health maintenance challenges. By the Ministry of Science and ICT, we are recognized as a future unicorn company. CB Insights nominated us as a global top 50 in advanced manufacturing. And year to date, we are a Series C company, and we have raised over $50 million in investments. Our mission is to enable digital transformation in industrial asset operation and maintenance through our digital expert platform. Now, the content we'll go over today, we'll start off by discussing an evolution of predictive maintenance. We'll go over enhancing equipment reliability through predictive intelligence. We'll do a Guardian 1 Turbo product walkthrough. We'll discuss predictive maintenance and enabling smarter decision-making in operation and maintenance. We'll do a Guardian 1 motor product walkthrough. And at the end, we'll have a question and answer session. So if at any point you have any questions, feel free to put them in the chat and we'll discuss them at the very end. I'll pass it on to Buddhi to get us started.
Thank you, Tyreace, for the introductions. So, picking up from the last webinar topic, that was industrial twins, basically talking about digital twins being a decision-making tool for industrial assets. Let's begin by understanding how the evolution of predictive maintenance looked in the years before and how it is right now. Predictive maintenance came to be by different practices, where traditionally it was very much more of a reactive strategy that enabled predictive approaches. On the left, we see reactive maintenance as fix it when it breaks approaches. Equipments are allowed to run to failure before any maintenance is performed. While this might be cost-effective in the short term, it frequently leads to high downtime and unexpected repair costs, as maintenance only happen after equipment have already failed. Next, we move to preventive maintenance, where goal is to prevent problems before they occur. This approach is time-based, with routine inspections and repairs scheduled according to historical data or manufacturer guidelines. Although this reduces the likelihood of unexpected breakdowns, it often results in over-maintenance, servicing equipment more frequently than needed. This can lead to unnecessary labor and added costs, sometimes without any real benefits to asset health. Today, we've shifted to predictive maintenance, the most advanced approach. This strategy uses real-time data and AI-driven analytics to predict problems before they happen. Rather than a reactive to failure approach, we can fix or schedule maintenance and do continuously by monitoring conditions of assets, using machine learning algorithms and AI models to forecast potential issues. And this has been a game changer, significantly increasing asset reliability while minimizing unplanned downtime. A crucial element of this, a crucial element that is driving this shift is industrial AI, which is transforming predictive maintenance strategies. By analyzing vast amounts of sensor data in real time, AI can detect subtle patterns and trends that humans human operators might miss. AI algorithms can predict equipment failures weeks to even months in advance, allowing teams to schedule maintenance where it's more in a more effective and a more efficient manner. Instead of wasting time or waiting till failures happen, we can rely on historical averages that not only extends the lifespan of assets but optimizes performance across entire operations, reducing downtime, repair costs, and the risk of catastrophic failures. Now let's explore how maintenance strategies have evolved from reactive approaches to a more proactive, data-driven methodology like predictive maintenance. First, we have reactive maintenance, which was used in industries, particularly in oil and gas pipeline infrastructure. For this approach, maintenance is only triggered after equipment fails. For example, if a pipeline motor breaks down, it can lead to significant downtimes, sometimes as long as 24 hours, and result in high repair costs. This results in delays in production schedules that can contribute to significant losses and unplanned failures that can be incredibly costly, both in terms of repair and production loss in production time. Next, we have preventive maintenance, which is commonly used in gas turbine power plants. Here, maintenance is scheduled at regular intervals, regardless of the equipment's condition. Gas turbine components like blades are inspected and cleaned every 3 months to prevent unplanned failures. While this approach reduces the risk of unplanned breakdowns, it often leads to over-maintenance, where equipment is taken offline unnecessarily. That also results in extra labor costs and downtime, where the equipment sometimes being serviced even though it's working fine. Finally, we come to predictive maintenance, the most advanced strategy, which is widely adopted in oil and gas industries. For example, offline drilling rigs often utilizes predictive maintenance by equipping vital components such as drilling pumps with IoT sensors. These sensors monitor vibration, pressure, and temperature in real time. For example, an offshore rig in the North Sea installed predictive sensors on its subsea pumps. The system used AI and machine learning to analyze the data and detect abnormal vibrations, which includes impending bearing failure. By scheduling maintenance proactively, the rig operators avoided potential breakdowns, preventing an estimated of 4 days of unplanned downtime, saving over $500,000 in production costs and repairing expenses. Predictive intelligence models help forecast and failures weeks in advance, allowing maintenance to be conducted during a planned production stop, ensuring operational continuity. Now, I'd like to paint the picture of what is predictive intelligence. To do that, I'd like to walk you through how the data flow looks like in predictive intelligence. So this slide illustrates and show the predictive intelligence and how it enhances equipment reliability by utilizing data-driven insights to anticipate failures and optimize performance across various industries. Let's start with data acquisition. The first step in predictive maintenance is collecting data from various sources. This involves a multi-channel data pipeline where data is gathered from sensors and control systems such as vibration, temperature, pressure, and other operating conditions. We also ensure compatibility with legacy systems through specialized interfaces. The data is then pre-processed using edge computing, which allows for real-time data analysis that is close to the source, minimizing latency and enabling faster decision-making. Next, we move to asset performance model. This model uses the data to assess critical factors like the machine health. The key here is that the model isn't static. It's continually evaluating real-time data to predict when and where a failure might occur. This allows companies to schedule maintenance before the issue leads to costly downtime, ensuring assets remain productive and reliable. Additionally, this model also measures repair effectiveness, helping refine and improve maintenance processes over time. Then we have the data management and model management. Data management involves organizing and structuring the collected data, where metadata mapping and data topology are used to create a digital framework. The goal is to optimize the flow of data in and out of the system, ensuring the right information is available at the right time. In model management, the focus is on keeping the predictive models up to date. This includes performance monitoring to track how well the model is working, training data updates through refining the model as new data becomes available, and even automated updates that ensure the system is continually improving. This is also complemented with a good UI interface that ensures the operator can easily interpret the results and act on systems recommendations. Overall, predictive intelligence allows organizations to streamline their operations, reducing unplanned downtime and optimizing performances on their assets. This combination of real-time data processing, asset modeling, and automated updates is key to staying ahead of potential failures and maintaining efficient and reliable operations. Now, what is the problem statement? We have millions of data and that we could use to our advantage and utilize them to do our predictions. What we've done with GUARDIONE Turbo is that we've mind mapped the entire process of what a SME thinks and created a technology around that digitizes their expertise. Basically going through similar steps as closer to what a SME does. We are very technology agnostic, where we can integrate with System 1, CM Insights, and other products, combine it, and provide real-time diagnostics. We've countered the need for an on-site SME, basically not replacing, but giving a second opinion, and emphasized turbo failure modes. I'd like to introduce GUARDIONE Turbo, a powerful tool for managing and diagnosing the status of turbo machinery by analyzing vibration and process data. It seamlessly integrates with control systems like PLC, DCS to provide a comprehensive real-time overview of critical assets. GUARDIONE Turbo is designed for assets like steam, gas turbines, centrifugal compressors, large rotating machinery like pumps and fans. Its key strength lies in the ability to detect and analyze 15 different failure modes in real time, while also providing a digital twin, which is a 3D render of the model of that asset for precise monitoring. Additionally, we provided features such as a digital expert that would provide expert-level diagnostics even without an on-site specialist being around. Further, we generate prescriptive reports that offer insights into diagnosis, fault isolation, and recommended actions on how to overcome the issue before they happen. This allows operators to make fast and data-driven decisions. I'd like to walk through all the key features in a little bit deeper. This is how we enable comprehensive diagnosis for large rotating machinery. At the heart is the 15 different failure modes that we diagnose. These failure modes include common issues such as unbalances, misalignments, rubbing, and oil wells, amongst others. What sets our system apart is the ability to integrate vibration data with process data like temperature, pressure, RPM, and more to create a full picture of the equipment's health. The data is processed in real time, helping the system detect potential issues early, long before they lead to costly failures and downtimes. The key to this capability lies in the system's deep analysis of multiple data types. For instance, vibration trend prognostics track patterns over time and predict the remaining useful life of critical components. This allows maintenance teams to accurately forecast when and where issues might occur, enabling proactive maintenance scheduling while significantly reducing unplanned outages. GUARDIONE Turbo also provides in-depth data visualization to assist in diagnostics. It generates detailed analysis and views like waterfall plots, which shows frequency versus time to visualize vibration characteristics changes over time. Obic diagrams offering insights into shaft's movements, revealing whether it's operating as expected or if there are potential misalignments or rubbing. And also we do board and polar plots which are used to interpret the phase and magnitude relationship between different vibration frequencies, offering deeper insights into rotor dynamics. These tools help engineers precisely isolate failure modes, whether it's thermal sensitivity, rubbing, or unbalance, ensuring that corrective actions can be taken swiftly. In conclusion, GUARDIONE Turbo combines comprehensive diagnosis with advanced data analytics, giving maintenance teams not only real-time view of current conditions, but also the ability to anticipate future problems. Going further on the key features, let's talk about the digital twin aspect of this. Imagine you have around 50, 60 assets. You're able to remotely visualize and see which asset is functioning normally and also get email notifications that trigger where an issue or an event is occurred. This isn't just a visual representation. It's a live dynamic tool that allows operators to monitor equipment in real time. Digital twins simulates a variety of operational scenarios and conditions, providing a clear view of potential issues before they happen and before an escalation comes to play. By identifying anomalies early, we help avoid costly downtimes and allow maintenance team to plan their maintenance with data-backed insights. In today's industry, one of the most pressing challenges is the shrinking of the labor markets. We no longer have hundreds of resources readily available to handle diagnostics and repairs. This is where Turbo shines. It reduces the need for large teams by automating analysis and diagnostic processes. Whether you're a frontline technician or a part of the engineering team, the system ensures that fewer people are needed to manage complex machinery, freeing up human resources for more critical tasks. Stakeholders at every level can be rest assured that their assets are monitored and managed effectively, even with reduced workforce. Also, we bring along a prescriptive reporting feature. These automated reports do more than just diagnose faults. They offer specific actionable recommendations with root causes of what has happened to your asset. By taking the guesswork out of maintenance decisions, they help streamline the process, reducing the time between detecting an issue and resolving it. This is a game changer for middle management, who are responsible for overseeing the entire operation. They can now see real-time reports that offer clear insights into the health of their machinery and systems, allowing them to focus on strategic decisions rather than getting caught up in the details of everyday maintenance tasks. Let's also talk about the digital expert feature. This is the feature which emulates the knowledge of the industry's top specialists, backed by our R&D team that we provide. In the past, operators have heavily relied on SMEs, but what we've done is we've provided this with a digital approach that acts as an expert, offering deep diagnostic based on AI and data analytics. Even in situations where an on-site SME isn't available, the system provides expert-level insights to guide your maintenance teams. This is particularly crucial in high-stakes industries like oil and gas or energy, where the speed and accuracy of decisions can significantly impact operators. So how does this help your stakeholders? For senior management, it's all about early support, catching potential issues before they snowball into major problems. For middle management, it's the visibility that on ongoing operations and helping them make informed decisions in real time. And for the frontline workers, it's like having an extra opinion and a separate expert eye, guiding them through the complexities of diagnostics and maintenance. We empower teams to work more efficiently, making sure that they make the right decisions at the right time without relying on manpower. We'll walk you through some real-world cases where predictive intelligence has made a significant impact for a customer in the energy sector. In this case, a centrifugal compressor was experiencing abnormal vibrations that their existing monitoring systems failed to detect. These undetected vibrations posed a serious risk of unplanned downtime and costly repairs, threatening the stability of the operators. So what was the result? Our predictive solution, powered by GUARDIONE Turbo, identified the root cause, which was fluid instability within the labyrinth seal that led to asynchronous vibrations. These vibrations were triggered by changes in the process gas composition. Pinpointing the exact cause was crucial and not only solving the immediate issue, but also preventing future failures. Now, how did we achieve this? Today, we live in a world where we can measure operational and vibration data using sensors and advanced tools. But sometimes with data, identifying the problem can be really challenging. It often requires the SME's evaluation to analyze the data. However, with AI, our tool was able to analyze this almost immediately. This is what we refer to as predictive intelligence. Let me break down what that looks like. Predictive intelligence reflects an SME's workflow. Usually, this is a stringent process that takes a long time to understand. But there's a common theme where the SME is needed behind a computer to do this analysis. We've encompassed that all into our tech. Our AI-driven platform analyzes data from the VMS and the DCS systems, including inputs like gas flows, general bearings, and compressor specs. By recommending an anti-whirling structure, we resolve the issue, saving the customer 3 days of downtime and around $65,000 in costs. This is another case study. We begin with a scenario that many operators are familiar with. Here, a customer experienced an unexpected trip event in their gas turbine during normal operation, which led to a sudden shutdown. Despite multiple attempts to analyze the situation, the exact cause of this trip remained elusive. Adding to the complexity where the potential for a liability dispute between the operator and the manufacturer was also coming to spur. With both sides needing an objective diagnosis, the situation demanded reliable data-backed insights to resolve the issue quickly. With GUARDIONE Turbo, our system conducted a comprehensive analysis by leveraging high sampling vibration and DCS data. It identified rubbing near bearing 2 and the key factor that was contributing to the shutdown. This diagnosis was breakthrough, not only explaining the cause of the failure, but also helped prevent a potential liability dispute by providing an objective, data-driven solution. Thanks to this analysis, the customer was able to take swift actions to prevent future incidents. Now let's explore what made our approach a little different and the recommended actions that brought this conclusion. Unlike traditional systems that primarily rely on DCS values, Turbo implements a multimodal approach, integrating high-frequency vibration analysis and data-driven diagnosis. This allowed the system to continually analyze historical vibration patterns and alarms, leading to the identification of rubbing near the second bearing, a factor that has been previously missed by conventional methods. This data-rich, real-time diagnosis brought clarity to an otherwise ambiguous situation, giving the customer immediate and actionable insight. Based on our findings, we recommended installing anti-rubbing enhancements and inspecting the alignment of the affected bearing to prevent future trips from happening. If I was to quickly explain this UI, the first image represents the rotordynamic analysis, which is visualizing the alignment and movement of the rotor across various bearings, with corresponding vibration and temperature data for each bearing. Anomalous behavior is detected near bearing 4, indicating a high vibration amplitude in the red zone. The second image displays frequency spectrum graphs, comparing the main vibration data against reference data at 3600 RPM. The peak amplitudes at certain frequencies suggested potential rubbing or unbalance issues that contributed to the equipment's trip. We were able to save around 20 days of unplanned downtime and about a little over 1.5 million in saving. This is my last case study that I wanted to walk you through as well. This is another case study from the energy sector. A customer experienced high vibration during a startup of a gas turbine generator. With no on-site experts available, They needed an immediate solution. Using VMS data from previous shutdowns and DCS data monitoring, the generator's winding temperature, our AI platform identified the root cause, which was thermal sensitivity due to localized heat generation in the generator. This is potentially caused by short circuits or winding entanglements. What our system did was we identified that root cause and gave an idea what caused the localized heat. This was a result from localized short circuits or winding entanglements inside the generator. Thanks to real-time data analysis, actionable insights were provided, allowing the team to act preemptively and avoiding further escalations. As a result, the customer saved approximately 7 days of downtime, which translated to around 683,000 in saving. This was a clear example of how our AI-based predictive maintenance solution can swiftly resolve critical issues, even when the human expertise isn't immediately available. Again, to quickly walk you through our UI, the top image shows the diagnostic interface of the gas turbine generator, detailing various components, which is at the HP, LP, and also RPM, plus the power output. And below that, you could see the vibration analysis on bearing number 3, where an unbalanced issue was diagnosed by FFT analysis and orbit diagrams. This visualization helped resolve problems easier and gives you a downloadable PDF that you can attach and send it to management so that they could also understand what is going on. That is the end of the GUARDIONE Turbo product. I would like to hand over the presentation to Jay to continue on the GUARDIONE motor.
Before we jump to GUARDIONE motor, I will talk about traditional method to maintain industrial motors. Electric motor is one of the most crucial components to our industry and infrastructure. Traditionally, we need to check industry motor one by one. Vibration sensor to detect mechanical fault, current sensor to detect electrical fault. Motor need to be shut down to measure insulation resistance. And motor meters, power meter to detect quality of current. Large industry facility have hundreds, thousands of crucial motors on their site. How are we going to cover that? Traditional methods, such as IEEE, IEC, typically takes vibration and temperature, which kind of works, but it was designed for condition monitoring at best. Not predictive, not prescriptive maintenance. Sure, there are signs such as unusual sound, excessive vibration, overheating, and decreased motor output. Traditional methods could detect abnormality if the problem is severe enough, but it doesn't tell you the root cause of it and then how to fix that. And you still need a subject matter expert to analyze data. In real life, it's already too late. Critical asset cannot be powered down without proper plan due to overall workflow of the facility, and replacement motor can take weeks, months, even longer to deliver to your site. When it comes to operation maintenance, early detection is key, and traditional methods cannot provide that, nor provide prescriptive and predictive solution due to its limitations. We need physics-based data-driven and end-user focused product that provides accurate and reliable prescriptive and predictive solution for everyone, no matter how expert or beginner you are. That is why we designed the GUARDIONE motor. GUARDIONE motor manage and diagnose mechanical faults, electrical fault, and energy efficiency by analyzing electric currents, which provides reliable prescriptive and predictive solutions. Let me talk about some of the few key features. GUARDIONE motor's hardware is easy and quick to install, cost-effective, non-invasive, and compact. and you just need locate power source, target motors in your MCC unit, and clamp the CT sensors to target motor, install the data acquisition unit, power supplier, and circuit protector, and compact stream-based router on your DIMM rail. Connect the plug and power up is ready to go. With AWS Cloud, your data is safe and secure. As you can see on the far left side of the picture, our data acquisition unit is compact compared to modern iPhones. Also it's in-house design and manufacture. Therefore, we are not depending on certain manufacturer. Orange primary data acquisition unit can be connected to nine of white secondary data acquisition units, and each data acquisition unit can handle 2 motors. Other hardwares are transducers and other General Electric, replace easily with current product in the market if necessary. Physics-based algorithms incorporate existing knowledge in forms of mathematical models, which enable timely and accurate prediction with less data, and their results are explainable. However, it has its limits and errors. ONEPREDICT overcomes existing motor current signature analysis limits. For example, all induction AC motor has motor slip. Motor slip is rotating speed difference between physical shaft and electromagnetic field, which reduced general motor slip error from 5.8% to 0.07%. Because all calculations based on MCSA, GUARDIONE model reduced misalarm and false alarm by significantly. ONEPREDICT filled the gap of physics-based limitations by much improved motor current signature analysis, domain knowledge, industrial AI, with a real-time dynamic threshold. Traditionally, you need to inspect motors one by one, and some of the motors located deep underground hazardous areas so that you cannot access it easily. Even worse, to inspect the electrical port, the motor needs to be shut down. Our product diagnoses mechanical faults such as bearing and shaft, electrical faults such as router and stator, and energy efficiency such as total harmonic distortion and loop mean squared in real time. Winding short in stator is one of the hardest faults to detect, and GUARDIONE motor is only product that detects early stage of layer short on winding in stator with higher accuracy. It's a complete package. There is no reliable comprehensive solution in the market to predict industry motors' health and possible barriers. By combining much improved motor current signature analysis, domestic knowledge, industrial AI, and the real-time dynamic threshold, we can predict near future's motor health with 96% accuracy and less than 1% of false alarm with email alerts when motor status change. All of this can be viewed by real-time based digital twins, which can be accessed any device with internet capability with unlimited number of users. It is convenient to manage multiple facilities on one page. With all the previous features, we provide not only cause of a problem, but also its recommendations to help you make an informed decision in timely manner. For C-level, it allows maximize overall profit and minimize operation cost. For asset manager, it increases management efficiency and safety by early detection with predictive maintenance features and decrease unwanted incident and accident. You can plan ahead of time. It allows gradually reduce dependency on subject matter expert with advanced digital expert. SME are dying breed, and they are not always available and expensive. For field engineer, It reduces workload, therefore they can focus on their attention to most critical assets. It's simple but complete. Let's talk about case of a Guardian model. The GS Power, one of the major power plants in South Korea, were experiencing some vibration issue of some of their motors. Due to the huge site with thousands of industrial motors and lack of experienced maintenance engineer on the site, the client needs a more efficient way to monitoring and manage numerous remote equipment in the facility continuously. As technology evolves, we will only need more industrial motor to keep up with our current consumptions. Traditional methods can detect abnormality if problem is serious enough, but it doesn't tell you what's the root cause and how to fix it. And you still need a SME to analyze the data. Replacement of a motor also could take a long time as well. In reality, it's too late. This will most likely cause downtime to your facility. Guardian motor was deployed at the client side. Soon after, our product detect abnormality of the target motors and provide a comprehensive diagnostic with root cause and each recommended action with prediction of 18 days before motor failure on October 20th. On November 7th, target motor shut down due to vibration of shaft, which damaged insulation between the stator. Just by implying Guardian motor, the client was able to improve OME efficiency by 40% and reduce unplanned downtime by 50%, and downtime cost saving nearly $1 million. Another use case, GE1, the largest LPG supplier in South Korea, were having a hard time to manage using conventional detection techniques such as vibration and temperature. The target motor is submergible pump that buried deep under the ground, which is critical asset to operation. To make it difficult to manage using conventional methods such as vibration and temperature. Therefore, there need a solution that provides comprehensive diagnostic coverage over mechanical, electrical, and energy efficiency with high accuracy. Traditionally, you need to check the motor's fault. You have to access the motor, which not always available because it's due to its unique location. To even worse, to check the electrical port, the motor need to be shut down. Sure, traditional methods might detect abnormality problem if the problem is severe enough, but again, it doesn't tell you root cause of it, and it doesn't tell you how to fix that. And you still need the SME to analyze the data, and they're not always available. And then not to talk about replacement motor, how long it could take, and in process of installation, it's for sure that this will cause downtime to your facility. Guardian motor was deployed at the client side after completing training period. Our product detect the stator on caution and shaft is high on caution on November 8th. The stator's winding abnormality is one of the hardest fault to detect. And even if you detect it, it's almost always too late. And then just to confirm that it's just stator's winding issues, motor have to be shut down, which for critical asset like this one, it's not possible because it would jeopardize the operation. On November 17th, stator is high on warning. On December 1st, stator is on warning and shaft is high on warning. On December 10th, motor shut down as expected. By combining advanced algorithm, multi-domain, domestic knowledge, and industrial AI with a real-time dynamic threshold, Guardian model was able to detect the early stage of stator winding issues and distinguish force mode between stator and shaft. Our product detected 32 days in advance, which allowed plan for the expected motor shutdown. The Guardian model's key features, such as comprehensive diagnostic with early detection, digital twin, predictable and prescriptive maintenance, the client was able to improve OMEG efficiency by 35%, reduce unplanned downtime by 30%. The client decided to expand the Guardian model at another site. Another use case is SK Energy, one of the largest energy company in South Korea. They were having a hard time to manage using traditional methods, such as vibration, temperatures. Traditional methods require inspect motor one by one, periodically. When you have thousands of mission critical assets, it's not possible. It's not easy to do, and it's not possible, and require many manpower specialists on their side. In reality, there are only few field engineers and then few SME on the site. It is not effective. It's not practical. Many of motor went out due to status winding short and other complicated fault modes. The client need more efficient, more comprehensive, more predictive solution to manage their assets. Traditional methods, again, could detect abnormality. If it's serious enough, then again, it's too late. Best defense to unplanned downtime is early detection, and traditional methods cannot provide that. By combining our unique algorithm, our domestic knowledge, industrial AI with real-time dynamic threshold, we are able to provide a prescriptive and predictive solution with high accuracy, with low false alarm. After deployment of a Guardian model, we are able to detect the early stage of status winding shorts ahead of time, which allow client to make informed decisions in timely manner to reduce unplanned downtime and operation cost. With Guardian model, the client was able to improve OME efficiency by 35% and unplanned downtime by 20%, and reduce operation costs of 25%, which is quite significant. Now I'll pass to Tyreace for Q&A sections.
Again, thank you for tuning in to our last webinar for the year. If you guys have any questions, feel free to reach me at my email on the presentation here. My phone number is listed as well. And thank you guys for joining us.